Okay, so I'm gonna be honest with this one. This one, the first time I started to record this, I hadn't looked at this for a minute, and it's confusing. So we have to go through very carefully to diagram this problem. So it says, at what temperature will a sample of nitrogen gas with a volume of 328 milliliters at 15 degrees C and 748 milligrams of mercury occupy a volume of 0.898 liters at a pressure of 642 millimeters of mercury? So you've got to be very careful to make sure that these correlate together. And so if you kind of ignore the rest, so with a volume of this, and this temperature, and this pressure, these three need to be together. So this is V1 and P1 and T1, which I need to convert into Kelvin. 15 plus 273, 288 Kelvin. And then this volume and this pressure correlate. So this is P2, geez Louise, this is V2 and P2, and this is T2. So it's asking, if you take a sample and you know that the volume, pressure, and temperature correlate in this manner, what temperature do you need to get that sample to for it to have a volume and pressure that meets these? So it is a complicated problem to analyze. Okay, so P2, I cannot talk today. P1 here is 748 millimeters of mercury. The temperature one here is 288 Kelvin, and the volume is 328 milliliters. Now I want to do my others, P2, V2, and T2. My P2 is 642 millimeters of mercury. My V2 is 0.898 liters. So I have milliliters and liters, so I need to be consistent. So let's just do 898 milliliters. Could have gone the other way. I just need to have a consistent unit. And then my temperature here is my unknown. And this is going to spit out, we want to go ahead and say a Kelvin temperature. And then I can see I have an answer here in degrees C. So we're going to have a little bit more work to do. My equation, P1 times V1 times T2 is equal to P2 V2 T1. And I'm solving for T2. T2 is equal to P2 V2 T1 over P1 V1. T2 is equal to my P2 value, 642, my V2 value, 898, my T1 value, 288, my P1 value, 748, and finally my V1 value, 328. Okay, so 677 Kelvin. To get that into degrees C, I do 677 minus 273, which is then equal to 404 degrees C. So if you're asked for a final value in degrees C, you have to do the calculation in Kelvin. Temperature must be in Kelvin. And then at the last step, convert back to degrees C. You cannot go through the calculation itself with the temperature in degrees C. Everything else is fair game. The pressure units, just as long as they're consistent, can be whatever. It can be torr, it can be kilopascal, it can be atmospheres. Same thing with the volume. The volume can be milliliters, liters, whatever units, as long as they're consistent, but the temperature must be in Kelvin for the calculation to work.